to give my screen. Okay, again.
Now we see your screen.
Yes, and now let's make it a full picture. So, okay, so publish or perish. And this is something, well, I announced it as a session where you get true advice. And I think it is very important for all those who want to make their path in science to think about the role that publications are really playing. I mean, there is a lot of sayings that go around, and I think we should be careful in what we really believe. So what you see currently is that we have the archive at the Cornell University, and many people upload the papers, so there is no quality control, there is no guarantee that it is novel content. So everybody throws their material in there, and what you get is you get a non-filtered, amazing chunk of publications. And this is, of course, the reason why we already had institutions like journals and conference program committees that do some filtering out of it, so that it not becomes like the archive where all and everything is published, but that there is some quality control. So originally, the process of publication was meant to filter all this, what is now at the archive, to be seen. Okay, so in this short talk for our discussion as a playground, establishing a playground for us, I want to talk about the impact of publications for science, organizing scientific discourse for falsifying hypotheses, and I consider papers as letters to colleagues and citations as part of the dialogue. And of course, this already is a bit different from regular rumors going on. And then how to do good science and writing is very important, of course. And then comes the impact for the scientists, and their ranking is the business. And that is what all the rumors are around, is that all the publication is just to get a good ranking, and a good ranking will give you a good job with a high salary or something. But the question is that quality control? Okay, so we go through that, and then I want to talk with you about your goals in science, writing, citing, and publishing. And yeah, maybe if we do not record that, you can just frankly put into words what you really are aiming at. And I think that is very interesting, because if many people do that, then we see there are many, many different views of science. Okay, so the process of science is a cycle of exploring, and then forming a hypothesis, then doing experiments and evaluation to see whether that hypothesis really holds, and then draw a conclusion. And then the controlled hypothesis testing is the difference between science and everyday thinking, where we say, aha, of course it is raining because I don't have my umbrella with me. You see, that is the everyday science. And let's see here a nice example from physics. Can apparent superluminal neutrino speeds be explained as a quantum weak measurement? And the abstract was probably not. So let's see, there is the hypothesis and there is a testing, and this is a very short sketch of what science is about. Then we need a scientific discourse for quality control, because on the one hand, attention is a very rare resource. You cannot read all the papers, you cannot see all the videos. So actually your attention is a rare resource, and someone entering the dialogue that is to be taken into account by every scientist in the field. The entitlement must be controlled so that only well-presented and novel arguments enter the flow, and no repetitions of known arguments without citations enter the flow. And so a program committee is the watchdog that watches the access to the floor so that your attention is saved. And here we see another nice example, the unsuccessful self-treatment of a case of writer's block. And portions of this paper were not presented at the annual American Psychological Association convention. And then it was published without revision. You see, there was no, and I will show you the review. The review of that paper was, I have studied this manuscript very carefully with lemon juice and X-rays and have not detected a single flaw in either design or writing style. I suggest it to be published without revision. Clearly, it is the most concise manuscript I have ever seen, yet it contains sufficient detail to allow other investigators to replicate Dr. Upper's failure. In comparison with the other manuscripts I get from you containing all that complicated methods in detail, this one was a pleasure to examine. Surely we can find a place for this paper in the journal, perhaps on the edge of a blank page. So this was the review, and it has all the things that are important, the summary, the relevance, the significance, the related research, the expression, technical detail, figures, tables, and references, and it was a perfect paper. So a paper is a letter to the community asking for critique. Yeah, so when you publish, you are not asking for applause, you are asking for critique. And then there is something I would like to know from you later on. While writing a paper, what do you think? For instance, you might think, this I have done and then I did that, and then you write it up. Or you might think, I did exactly what all these cool people do, and this time it's me. Or you might think, oh my God, this will not be of interest to anybody, but my professor pushes me, I have to submit it. But you may also think, this is a letter of me to particular people whose paper I have read. And then I'm writing, your hypothesis is partially supported by my result, but there are restrictions. And you also stated restricting assumptions, but they do not cover all the necessary cases. Look, with this formulation now, we get a new hypothesis, which is fully supported by all the observations. And then you say, yippee, I got it. Then very important is to get into contact with the colleagues, with those fascinated by the same subjects. So you find those that are really concerned about the same things that you are, and you invite them to a common paper, you organize a workshop together with them, and you collaborate. And by the way, thank as often as you can. So I think we often forget to thank all the other people that inspired us and on whose grounds we are building our hypotheses. So, and remember that attention is rare, so make sure that your paper is worth the time of reviewers. Citations. So, the letters are addressed to someone, okay? And letters are read by members of the debate cycle. So you say there is this little, so let's say a resource where machine learning, and there are the people that are concerned about communication and distributed learning. So then you write the letter to this community of communication aware distributed learning. And these people are the members of the debate cycle. They read it and they do the critique. And if you stay in your cycle, then you get more citations. And if you stay in that cycle a lifelong, then you are the expert of this particular tiny piece of work in science. And then you get very many citations. But maybe you prefer new challenges. And maybe you are content with what you achieved in one discourse and then you move to the next. And maybe it is too much repetition in the club so that you leave. So this will, I can tell you, this will decrease your Hirsch index, but maybe it is what that you want to do. Okay, and then there is this wonderful, I don't know whether you know even Q. I mean, I recommend reading his papers very, very much. I think he is not only the best writer of papers, but he also gave a wonderful tutorial on how to do good research, get it published in CICAD, and get it cited. And he had the one nice schedule of how to do research. You find a problem together with the data. So you do not find a problem if you don't have data. And you do not have data that are useful if you don't have a problem. So you start writing, that means you start writing before and during research. Then you do the research, you solve a problem with several circles and many failures, and then you finish most of the draft and send this preview to mock reviewers. That is normally the professor. And to the rival. So if there is one person that does very similar work, but not exactly the same, then you send to this person, you send your draft and say, hey, what do you think about it? And then you get revisions and you revise the text and then you submit. Okay, so that is really a good schedule for how to write a paper. And the paper is about science, it is not about you. So never write, I first did, and then I did, and so on. But you write, the proposition A does not allow to do B. But our proposition A dash allows to do B dash, and then you argue why B dash is okay. In the end, show that A dash does what it should, and B dash is not exactly B because ABC is missing, but it is sufficient for some other performance. And then you conclude with writing what you would like the reviewer to write. So do not complain after the reviews. Oh, the reviewer didn't say that I was the first to write this. No, you write in your conclusion, I am the first to write this to the best of my knowledge, of course. Yeah. So what you always have to take care of is that this is your reviewer. I do most reviews after midnight, and this is not very good for the quality. But you see, doing revisions is not part of our regular working routine. We do it regularly, but not within our working routine at the daytime. So we have to put it at the end, and therefore we are tired. We need to be treated nicely because we are a bit stupid at that time of the day. So we come back to the unfiltered messages in archive, and that it would be important to have a good critique and revision and guarantee that it is novel and so on. So that is the pure science. And of course, that is idealistic. That is how it should be. This is what I would like to have. And now let's come to the impact for the scientist. And there is crawled publications, and then they are ranked by citations. And what I wanted to show you here on my example is that the different crawling engines give different results. So here is my profile at Google Scholar, and here is one by Microsoft Academic Search. And then you see, for instance, that the same paper can be viewed, the different versions could be separated and so on and so on. Well, and things like that. And the different profiles can be also there. It is not truly reliable. That's what I want to say about it. And as you also see, you do not get a high Hirsch index if you change subjects more often and do not stick to the one thing you always had in the beginning. Okay? So what is this magic number Hirsch index? That was Jorge Hirsch. The venue of publications is not taken into account. So if you have a lot of publications in a B or even C journal or conference, and all these little group of people cite each other all the time, then you get a nice Hirsch index, although you never published in an A-star conference. Also, the number of co-authors is not taken into account. So, what is the Hirsch index? You have your publications, and you rank them according to the citation. So that you have one with many citations here, and then here is one that has 5 citations. And if then, so that is this ordering. And then you have here your publications, and then, so if then you get the Hirsch index of 5, if at the 5th position you have 5 citation, okay? And then if at the 6th position you have less than 5 citations, then it is no longer counted. So it means that if you have a long tail distribution, the Hirsch index indicates where is this kind of a move downstairs here. Okay, so that is it. Okay, so is this quality control all the citations? I mean, the rationale behind it from Jorge Hirsch, of course, was that he said, if so many people want to cite it because they used it, it must be very important. So that's the rationale behind it, but maybe it's not quality control. And this is my picture of encouragement. The master has failed more times than the beginner has even tried. So that is why I think that critique is very good and quality control is good also for the individual scientist, because then you know, okay, I didn't make it clear enough. My formulation was not easily understood. I have to do it better. And then all these throwaways really make you the master. So you have to submit 4 papers to get one, and one of the 3 rejected ones becomes possibly a best paper in the next year. So quality control. And now I want to know things about you. I would like to know who you are in terms of your grades, and then in terms of whether you did publish already, and then where in machine learning your interest lies, which machine learning models, which data, and then more generally, what are your goals and how would you like science to be organized? So you see all these questions I have for you, and I am very, very curious. So I would like to give you the floor.
All right, I'm stopping the recording.